Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 2511, maximum enemy forts that can be captured. So before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes before jumping into the solution. So let's get right into it. What problem is asking that you need to move your army from your fort I to the empty position J. This is very important. Empty position J. What do I mean by empty position? Is -1. So you can move your army from your fort. 1 indicates your fort. So you can move your army from your fort to an empty place. This much is clear. You cannot stop your army at the enemy fort. Enemy fort, I mean 0 0. You cannot stop at 0 0. You can only stop at -1. So that much is clear. What you have to do, it doesn't mean that you have to only from left to right, you can go from right to left also. And this is what problem is asking. You have to return the maximum fort captured. So in this case here we captured 3, in this case we captured 4. So what we should return is 4. I hope problem is clear what it is asking and how we are handling it. So this much is very clear that whenever the value, not the value, the sign will be opposite, then what we will do, we will calculate the enemy fort captured. This much is clear that whenever we have opposite value, this means that we have found the empty place, and now what we have to do is we have to see how many enemy forts we captured. So what is the thing that we can do, or which algorithm we should use? I think two pointer. Why? Because we will increase one pointer to an extent, and whenever this happened, we'll just calculate what the number of forts the enemy the number of enemy forts we captured. So this much is clear. Why two pointer? Why? Because we have to get that segment. In order to get that segment, we usually use two pointer, or you can also call it sliding window with variable size window. Both are same thing. Two pointer or sliding window with variable size window. Also, if you are not clear with it, I have a playlist over it. You can watch it to have more clear thoughts about sliding window, two pointer, or whatever you want to learn. So this much is clear. Why I am saying opposite sign? Because you cannot do this. You can do this, but it also means that we have the empty fort and the fort that we have already. So we can go this left to right only, and whenever again the sign will be opposite, then we calculate it. So this is our algorithm. What we are doing is initialize two pointers. We will keep on increasing the I, and when we encounter opposite sign, what we do, calculate the enemy, not energy, enemy fort captured. This much is clear. But there is also other case. If the sign is not opposite, something like this. If sign is not opposite, something like this happen. Will you calculate? No. You should do is what you should do is swap your, not swap, place your j over here. Place your j over here because I is traversing forward, j is at the back. So calculating from this is not a good idea. This should be considered. So we will just change the position. What we will do is here, I'm writing over here, if above, what do you mean by above is this condition, this one. If above condition fail, that means sign are similar, then what it means that we cannot find the enemy fort that we have captured, because it will just overrule the basic condition that we have to start from our fort and stop at the fort empty place, not at the fort, empty place means -1. So that is what I'm trying to say is, and also this is done to minimize miscalculations, because these forts are not captured, these forts are not captured. That's what this condition will do. So what you do is j is equals to I. That is it. If the signs are not opposite, let's do a dry run. Zero. What was the test case? 2 zeros, then 4 zeros, 1. So we are at this. Let me dry run the code only. Let's see the code, then I will dry run the code so that video can be short. So this is the size, this is the result what we would return. Okay, these are the 2 pointers what we initialized. I is equals to 0, j is equals to 0, and I can go up to which length? To the size, and I plus plus. As you can see, let me zoom it a bit. Zoomed too much. Yeah, as you can see, if fort is not equal to 0, what do I mean by not equal to 0? This condition, when we encounter 1 or -1, because when there is a 0 we just increase our I, because calculation of length, not length, the enemy fort that we have captured. So if it is not equal to 0, that it means it can be -1 or 1. What we will check is that if j or I have opposite sign, if they have, what we do, calculate the result. If not, if this doesn't happen, what we do, we change the position of j. And also if it does happen, then also we will do change the position, because it's very basic thing. If we have calculated this, would you keep your pointer over here only? No, you have calculated pointer should be over here. That is correct or not? Yeah, it is, because you have to shift your pointer. I'm just telling because sometimes it doesn't click in your mind, so that's why. This condition will always run. This will run only when they are opposite sign, and we keep on iterating. After iteration we will have our result. let's do a dry run of this over a test case so that you can have a more understanding what I wrote, because dry running algorithm doesn't make sense sometimes because code is sometimes little bit tricky. 1 0 minus 1 0 0 0 0 1. Let me index it. 0 1 2 3 5 6 7 8. Yeah, so first thing first, here is I, here is RJ. This condition is encountered, it's not equal to J. Are the sign opposite? Are the sign opposite? These are equal to each other? No. What we do? What we do? J is equals to I. So J is over here only. Again, I goes further. It's 0. It's 0. Again, I is encountered over here. What we do? We calculate. This is encountered. What we do? We calculate the, what we calculate? Calculate the number of votes, because this condition is now true. Minus and minus 1. This is equal. What we do? I, what is I? 3. J is 0. Minus 1. That's what we are doing over here. We got 2. Yeah, that is correct. We got 2 enemy forts. This much is all good. And also what we do is, after that, this line is executed and J is now over here. And again, I is this 0. No worry, no worries, no worries, no worries. Then something happened. Is this equal to each other? Minus 1 is equals to minus 1. Yeah, it is. So what we do? Again this time, 8 minus 3. Oh, just froze. What just happened? What just happened? Let's get right into it. Where were we? Yeah, 8 minus 3 minus 1. 8 minus 4, it's 4. So which is greater, 4 or 2? 4. So we will return 4. And I hope I was able to make the code very much clear, and also the, I hope algorithm is also clear. Just algorithm is just conversion of code, or code is the conversion of algorithm, vice and versa. I hope this is understandable what we are doing. I minus J minus 1. If it is not, watch my playlist. So let's submit it and see if it is running or not. Yeah, it is running. I hope I was able to make my intuition clear, and if I was, so consider subscribing to this channel, and you have to do what you have to do. So keep grinding. You guys are awesome. See you in the next one. Bye bye. And also like this video, and many of you don't subscribe, so consider subscribing it. So see you in the next one. Bye bye.